Hello and welcome to the Complete Regular Expressions Bootcamp. This course will help you go from zero to hero in learning regular expressions for all programming languages like PHP, Python, JavaScript, PERL, Ruby, etc. Regular expressions are such an incredibly convenient tool available across so many languages that most developers or data workers, data scientists, are going to learn them sooner or later. Well, the question is, why learn regular expressions? You may learn regular expressions for parsing and extracting data from text. It is a convenient tool and it makes your work fast and saves time. Manage data efficiently, searching, sorting and choosing the right information from huge amount of data. Stand out from the crowd. Better job prospects and career advancement, and simply to have fun. They are very interesting. Next question is why you should take this course. Because regular expressions are made easy here. Regular expressions are explained step by step in a very easy manner. Even a 10-year-old can understand and comprehend and can use them. You learn the logic and philosophy of Regex instead of cramming or just copying code. We have discussed idea and application, and you learn the skill, and there is value addition after taking this course. So the person who studies regular expression will not be the same after taking this course or after studying regular expression. There are plenty of examples as well as exercises to comprehend the idea. Regular expressions are usually thought of difficult, but here I have simplified this topic so that you understand regular expression without any problem. Each topic has examples for explanation and application. Just for an example, assertions, look around. The topic is thought to be a little difficult to comprehend. Here, after this course, anyone will be able to understand what are assertions, what is look ahead and look behind, and what is negative or positive look ahead or negative or positive look behind. Regular expressions are easy to learn and very powerful. They will make your life easy. Now, who is this course for? If you are new to regular expression, if you are a programmer of any programming language, or you have to deal with data in your daily life, or if you want to level up your regular expression skills. This course will be hopefully quite helpful for you. Now here is a brief summary of course. The course starts from the very basic intro to regular expression, the uses and application, then the tools and environment used for working with Regex. Then there are two sections of regular expression basics, setting a very strong foundation to work on. It includes the Regex syntax, characters, meta characters, modes, etc. Then there is a chapter of sets, quantifiers, anchors and boundaries, groups, back referencing, assertions or lookarounds. As I told you earlier, assertions are simplified here, and examples and how to plan complex regular expressions. Extensive exercises for learning purposes and comprehension. If you listen to these lectures and see examples and solve these examples yourself, and after every chapter there are exercises, solve these exercises, hopefully there is a very likelihood that you master regular expression and you will be able to use them in your everyday task and in your job. You would be confident to put regular expression on your resume. All this comes with a wonderful offer of 30-day money-back guarantee. So if you feel this course did not add any value to your current skill set, you get your money back. Hence, there is no risk associated with registering this course. However, if you register this course, there is an opportunity to advance in your career or get a better job. So what are you waiting for? This is an excellent opportunity to learn Regex. Enroll today. Thank you for taking out your precious time and watching this introduction to regular expressions video. See you inside the course. Hello and welcome to regular expression engines, tools and environment. First simple question would be, what is a regular expression? And the answer is, a regular expression, also called regex or regex P, actually it is regular expression, also sometimes called a rational expression, is a sequence of characters that define a search pattern. Usually this pattern is then used by string searching algorithms for find and replace operations on strings. You can think of regular expressions as wildcards on steroids. Now regular expressions are used in C, C++, .NET, PHP, Python, JavaScript, PERL, Ruby, etc. Now more than 90% of the regular expression syntax is same for all these programming languages. However, there are subtle differences between these. All of these programming languages have regular expression processing engine, commonly called as regex engine, and these programming languages, they are called, when regex is used with them, they are called different flavors of regex. Most of the syntax and rules and regulations are same and common. However, there are some differences also. This course covers regular expression for all programming languages, and then you can move on to a specific language. As you would know, 95% or more of the syntax and rules and regulation, and then you can apply 2, 3 to 5% of that specific programming language rules and regulations. So if you are from any programming language or you don't know about any programming language, this course is going to help you understand and work with regular expressions. Now the work environment and tools for regular expression. In Google, if you write online regex tester or online regular expression tester, you will get these results. All of these are good regex engines. I mostly use regex101.com or regex PERL, yes, here, or regex tom for .NET. Now I will like to show you one or two engines here. This is regex101.com. Now here you can select a flavor, like if you are working with PHP or PCRE or JavaScript or Python or Golang, etc. You may select your flavor, and as I have told you earlier, most of the things are just same, subtle differences. This engine is good for many reasons. It is very fast and accurate. Here you are going to write the test string. Here will be the text. So this is test string area, and this is regular expression area, or window bar, where you are going to write your regular expression. Here this engine gives you explanation why there is a match, why there is no match, and here match information, the number of matches and their position, and the quick reference is also available, and here explanation, etc. So overall this is a very good regex engine, and we are going to work in it. This is regex PAL, and this is also available offline, so you can work with it without being connected to internet. This is the testing area. Here you are going to write the regex, and you will be shown result here, like what is the match, so one match, etc. You may change the language or flavor from here, JavaScript, PCRE, and PCRE stands for PERL compatible regular expression engine. This is regexer.com, regexr.com. This is the area where you write the regular expression, and this is the text in which you want to search and match. This is also a good engine, and it is available online, of course. So these are a few online and offline regular expression engines. We are going to work in regex101.com, this wonderful regex engine, simple and efficient. Next lecture is start of regular expression basics part 1. Thank you. Hello and welcome to Regular Expression Basics Part 1. First topic is regular expression syntax or regex syntax. Now let's suppose we have to write a regular expression. First we put a forward slash like this. Then we write our regex and place a forward slash at the end. In simple words, we enclose our regular expression between two forward slashes. Now let's suppose you want to write the regex star. That means you want to match star in a string of text. You will write it as a forward slash. Then you will write the word star and another forward slash at the end. Another example will be if you would like to write or match the word tree, then forward slash tree and another forward slash. These forward slashes, one at the beginning and one at the end, differentiates a regex from the rest of the string or text. And this pattern or syntax is present in almost all of the flavors of regular expressions. Now let's apply it using regex engine here at regex101.com. This is our test string, twinkle twinkle little star. This is our test string and we write star here. Please note that we are not going to write the forward slashes here, as at regex101.com they have already placed forward slash at the beginning and at the end. Star is the word to match, and we can see this engine has matched the word star here. The word which is matched is highlighted in light blue color. So this is writing a very basic simple expression and matching it or searching it in the text string. Again, for second example, this is our test string. Tree provides us oxygen and we want to search for the word tree. We write tree here and it simply matches here. Now similarly, if there are numbers and we want to look for the number combination of 1 2 3 4, and here it matched, and this is forward slash and this is the another forward slash at the end. So the syntax of regular expression is you have to put the word, the search pattern in between two forward slashes. So very simple, isn't it? Similarly, the whole course is going to be simple like this. We will gradually move from very basic and simple things toward the complex things. Thank you. Hello and welcome to Regular Expression Basics Part 1. The topic of this lecture is literal characters. This is the most simplest match in regular expressions. By literal, we mean taking words in their usual or most basic sense. And characters, well, a single letter or a group of letters. Like alphabets or group of alphabets known as words. Now these words could have some meaning, or it's not necessary that they have some meaning. Just a single letter or group of letters or any combination of numbers like 1 2 3 4, like 9211. It is simply anything what it appears to be, just like A means A, B means B, cat means cat, car means a car, and a combination of numbers 9211 means 9211. Simple. And if you want to search either A or B or a cat or car in our test string, it will be the simplest match. We will just write these in the regex box and then we will search it in the test string. So the most basic or simplest search or pattern matching is literal character match, and no symbol, nothing complex involved, simply a character or a group of characters which we sought to match. Now moving towards our test area, regex101.com. Now here this is our string, test string. This is a car, this is my car, I like my car, it has a beautiful look, and we want to match a character literal A, and you can see it has matched A, and at more than one place. In fact, it not only has matched A, but anywhere it could find A. So there are total of, you can see here, 7 matches. Match information given here, there are total 7 A's in our text. So any occurrence of A, either as a single letter or in between any word, it will match that. To avoid it from matching A in different words, there is a special syntax or pattern for that. For the time being, A will match any A in the text, and there are total 7 matches. This is the match information box, and which will show you how many matches. You can see the matches here, they are highlighted here. The regex engine starts matching from the extreme left and then moves on towards right. For example, the regular expression is A, and it will look for, is this A? No. Move on to next one. This is A. H? No. This is A? No. This is A? No. This is A? No. Space. Then again A. No, this is I. S space A. Oh, this is the first match. You can see here, match 1, group 0 A, position 8 to 9. Position means the position of characters including spaces. So it is at position from 8 to 9, starting from 8 and going up to 9. Of course, is a single character. Then again it will go for, okay, space, no match, C, no match, A, okay, it is a match. So this is match 2, this is the second match. So A, this character literal A will match all A's in your test string. So simple, A matches A. Now let's suppose you want to match A as a single character. You don't want to match A in car or beautiful or has, etc. So then what would be the pattern? I am just writing it, we will discuss it later. Just we put boundaries here. Simplest method can be B and B. So now you can see here only two matches. This is a car and it has a beautiful look. But for the time being, we will discuss these boundaries later. We are discussing character literal. I just wanted to tell you that we can sort out and can match any specific letter or a set of characters. But in literal character, literal match, the word will match any occurrence in the test string and it will search from, it moves from left to right. Similarly, a B means simple B, here B. So only one match. This is B in beautiful, and it is part of that word. As this is the simplest match, so we are not discussing either it is a word or full word or it has boundaries, it is at the start, end, etc. Similarly, if you want to match car, and it will match all cars here, and you can see this is match 1, this is match 2, and this is match 3, and it is moving from left towards right. It will match all cars here. Actually, when we try to match a group of words, it works like this. It takes out the first letter from here, C, and it looks for C. This is C, no, this is T, H, I, S, so no C, a space, no C, I, no C, S, no C. So it keeps on searching and looking. Space, no, A, no, space, no, C, oh yes, this is a match. But hold on, now next is A. So just after C, is there an A? Yes, okay, that's fine. Then it looks for R. Is there R? Yes, there is R. Okay, this is the match number 1. So first it looks for C. If it finds, then it starts looking for A, and if it finds A, then it starts looking for R, and if it finds the whole combination, it highlights it and says it is match number 1. So if we write here can, car, call. Now by searching all here, when it moved up to here C, okay, it is C. Yes, this could be the case. Then A, yes, going in the right direction. R, no R. Okay, no match. Move forward. Okay, C, yes, C, A, yes, A, and R, okay, it is a match. Move forward, space, okay. So it starts searching for C, then after C, successive A, so it goes for C, yes, this is C, then it goes for A, okay, A, it could be a match. R, no R, okay, no match. And it moves L, okay, no match, and then the end of string. Okay, this is all. So there are 4 matches, match information 1, 2, 3, 4. So regex101.com is a very wonderful and amazing regex engine. It gives you plenty of information about matches and other explanations. For example, here you can see car / car matches the characters car literally, and if we write here as A, A matches the character A literally, so this is a literal character match. Similarly, if you want to match numerical literal character 9211, simply it matches any occurrence of 9211 and 1011 street, so it only one match. If you write 9217, it will not match it, because it is looking for a combination of a group of characters in this pattern. 9 after 9 2, after 2 1, and after 1 1, so it will go for 9217, no match, and 9211, yes, there is a match. And if it is 9211178, there will be also a match. If we want to avoid any matches like this, then we will have to set boundaries, like 9211 is a single word. In this lecture, you have learned how to conduct a literal character match in Regex, and simply matching words or a group of letters, characters, numbers in your test string. So this is also very simple. Thank you. Hello and welcome to Regular Expression Basics Part 1. In this lecture you are going to learn about regular expression modes or flags. Modes change the behavior of search pattern such that applying different mode will yield different results. So it is very much necessary to know about modes used in regular expression. There are a number of modes used in Regex, and some of them are quite specific to some flavors. However, I am going to discuss here 5 basic types of modes which are used in Regex more often. But before discussing the 5 different types of modes, first we discuss the syntax of a mode, how it is written. So the syntax is, we write the mode after the closing forward slash or the second forward slash. So first forward slash the regex, second forward slash, and after the second forward slash we write the mode. This is the common syntax for all modes. Now we are going to discuss the 5 basic cases of modes or flags. Sometimes they are referred as flags instead of modes. The first one is global mode, used very widely. Its syntax is forward slash regex forward slash g, lowercase letter g, and g stands for global. Now what does it mean? A global mode or a global flag means it will search for all the instances on all the lines. In simple words, it will match all occurrences, or it will search for a pattern throughout the string. Case insensitive mode, it will match without considering the case of uppercase or lowercase letters. It will just look for a word and it will show the match. The next two are single line and multi-line modes. For case insensitive we use lowercase I, for single line we use lowercase s, and for multi-line we use lowercase m as the mode letter after the standard regex syntax. Now single line mode, it just treats the whole string as a single line. Even if it is composed of multiple lines, it will consider the whole string, the test string, as one single line. And multi-line mode, M will treat your string consisting of multiple lines. So S mode, single line mode, will treat the whole test string as one line, and M will treat your whole string consisting of multiple lines. Now what will be the impact of this? We are going to discuss it later because we have not studied meta characters. So we are, for a time being, you just get this idea. Single line means treating your test string as a single line, and multi-line means your string is treated consisting of multiple lines. And no mode, or the standard mode, or without any flags. So forward slash regex forward slash. This will match only the first occurrence of your regex, of your search pattern, and will just return the first match, even if that word or that literal character or that number exists 50 times or hundreds of times, it will just match the first occurrence and will return it. That's why we use global mode more often. Now we are going to see the global mode, standard or no mode, and case insensitive in our Regex tester. In regex101.com, by default, the global mode or G mode is on. Hence, if we write regex here car, it will search all the instances of car, and car, because global mode means it will search for all the instances on all the lines. It will match all occurrences, or it will search for a pattern throughout the string, throughout your test string. So it is very obvious and clear here that car and the whole test string is searched here, and it has found 4 matches for car. Now if we remove this G, and these are the regex flags or modes, and if we remove global, then no flag and no mode, that becomes the standard. And standard means it will match first occurrence. Here you can see it will match the first occurrence of car, even though there is car here, this is car, but it will match only the first occurrence. So this is the difference between global mode and standard mode. Global mode searches for all the occurrences, and standard mode searches for the first occurrence, starting from left to right. One more example to see the difference between global mode and standard mode. Let's suppose this is standard mode, and standard mode will search for the first occurrence of letter A, and you can see this is the first occurrence of A, and it will stop its search there and match 1, full match A. Actually, in case of a standard match, only there will be one result at maximum at the and that will be the first match. It is also possible that there is no match at all. For example, if I write Z here, your regular expression does not match the subject string. Z matches the character Z literally, case sensitive, and it is not found here. So if I write A and I apply global mode, then it will match all the occurrences of A as a letter or found in between words. So there are a total of 12 matches here in this case. I hope that the difference between global and standard modes or flags is clear. So global mode and standard or no mode are discussed. Now we are going to discuss one more mode, and that is case insensitive. Single line and multi-line involve some complex symbols, and we will discuss them later. So case insensitive mode, by default the search is case sensitive. For example, if I write car here, it will match this car, this car, this car, and this car, because this car written is lowercase c, lowercase a, lowercase r. This car, this is written uppercase C, lowercase a, and lowercase r, so it is not a match. Similarly, if I write CAR, again it is not a match, because by default regex search or matching is case sensitive. it will only look for this specific case. Now if I apply case insensitive flag or mode, this is I, and it will result in matching all the occurrences of car, either it is a lowercase or capital or uppercase, and A and R lowercase, or all are in uppercase. So the word is itself is explaining and telling that case insensitive means it will search for all the occurrences without considering the case. And if we remove that, then it will become case sensitive, and it will match only those which are exactly the same case. For example, if I change it to capital C, okay, capital C, now it will match only this car, because this is structure is capital C, lowercase a, lowercase r, uppercase C, lowercase a, lowercase r, and it is not matching the other cars, even this car, because this is capital, capital and capital. It will exactly match the case of every letter. Now in case of C, capital A, capital R, it will match this car, because these all are written in capital. If it is like lowercase c, lowercase a and capital case R, now there is no match. Your regular expression does not match the subject string, because in our test string there is no car written in this specific case. If I write it here, it will be a match, lowercase a, lowercase c, lowercase a and capital R, so it is a match. So this is by applying case insensitive, it will match all the occurrences irrespective of the case, and like this one. And if I remove this flag, and it will search only, it will match only the given case of that word. So global means it will search for all the instances. No mode means it will match, it will show the result of first match. Case insensitive, it will match without considering case. Single line mode or flag will mean treating the whole text as a single line, and multi-line mode means treating your test string consisting of multiple lines. So these are the basic regex modes. Thank you. Hello. In this lecture you are going to learn about meta characters or special characters. Because we want to do more than simply search for literal pieces of text, we need to reserve certain characters for special use. Now, to understand the concept of meta characters, let's see this test string. Okay, the test string is, this is a cat, period. The color of this cat is white, period. John loves his cat, period. Do you have a cat? Question mark. John went to a village last year, parenthesis, 2017, parenthesis close, period. Now, if you want to search a literal character A in this test string, you will write A here, and you can see there is a match. Total there are about 11 match here, and it has matched either A as individual character letter, or it is within certain word like in cat and in have, etc. So this is literal match or literal character match. Now if you want to search the word cat, cat, so this regex has matched cat here, and there are 4 instances. So this is very simple. A means A and a cat means cat, and they match just normally like we have discussed in literal characters. Now if you want to match this question mark, or you want to match question mark in your text, you type question mark here, and instead of a match with this one, there is only one question mark in our test string. There is a pattern error. That means the match information is your pattern contains one or more errors. Please see the explanation section above. So it is an error. Similarly, if you want to match parenthesis, here is the parenthesis. Instead of a match with this opening parenthesis, again there is a pattern error. One thing is clear: matching a question mark or matching a parenthesis is quite different from matching A or matching a cat or matching a car. Question mark and opening parenthesis and closing parenthesis have special meaning in regex instead of their literal meaning. So we can say question mark and parentheses have special use in regex, and hence they are special characters or commonly called as meta characters. Okay, one more example. Let's suppose you want to match a dot, period in your test string, like here this is period, this is period, and you print a period here, and instead of matching this period, it has matched almost everything, every character, even spaces and periods. We were expecting that a period will match a period, but it has matched everything. This shows a period or dot has special meaning in regex instead of its literal meaning, and hence a period is also a special character or a meta character. So we define meta character as a meta character is a character which has special meaning instead of its literal meaning. And you are going to use meta characters in regular expressions to define the search criteria and any text manipulations. And most meta characters are errors, pattern errors, when they are used alone. Hello. In this lecture you are going to see the 12 basic meta characters with special meanings, and you cannot use most of them alone, as it will cause a pattern error. / of course is a meta character because it encapsulates your regex. In addition to that, the first and important meta character is \. Second one is caret, then pipe symbol. Usually on keyboard it is on the same key of \. You can use it with shift, then a period or dot, a $sign, question mark, asterisk, plus sign, opening and closing parenthesis, opening square bracket and opening curly bracket. These are the 12 basic meta characters, and they have special meanings when used in regex. This group of meta characters is called single character meta character. There is another group of meta character which we are going to discuss in later lectures, in which we use \ in combination with a literal character, and which creates a regex token with a special meaning. You have to be careful while using these meta characters. These characters are reserved for special use, and we are going to study these meta characters and other meta characters throughout this course. Thank you. Hello. In this lecture you are going to learn about how to escape meta characters. In the previous lecture we discussed meta characters, the characters with special meanings, and they perform specific function in regular expressions. And using most of them alone causes pattern error, or they produce unexpected results. But what if you want to match these meta characters? If you want to match a question mark or a parenthesis or a period, because simply writing here like question mark, it will raise a pattern error. Or if you want to match a parenthesis, again a pattern error. or if you want to match a forward slash in this URL, again a pattern error. So what is the solution? The solution is we use a backslash just before a meta character to escape it. Like here, this question mark is a pattern error, and we write a backslash just before it, and here this is a match. When we use a backslash just before a meta character, it makes a meta character just a literal character. Its special meaning vanishes, and now you can easily search and match any of meta characters just like any other literal characters. Similarly, a parenthesis, no match, instead a pattern error. We want to escape this and we want to match an opening parenthesis with literal meaning. Now we use a backslash and it has a match and the error is gone. Why? Because we have escaped this meta character, and this meta character opening parenthesis has become a literal character. Similarly, backslash period, and it will match only the periods in your test string. And for escaping a forward slash, this is forward slash and a pattern error. Using a backslash before it will escape the meta character behavior, and now it will match the forward slashes. Hence, the rule of escaping a meta character is using backslash just before that specific meta character. You can use this method with any of the 12 basic meta characters. Now, one more example with searching for a specific URL. Now, this is our URL and we want to search for it. By writing this specific URL here, https://www.mysite.com/folder/page.html. Exactly the same string written here in Regex, and it has created a number of pattern errors, 1 2 3 4 and these dots. Now if you want to match this URL, we have to remove the errors. By examining our regex, we come to know that our regex has two types of meta characters: forward slash forward slash forward slash forward slash. So 4 forward slashes, and period, period and period, 3 periods, forward slash and period. We will have to escape these meta characters one by one using a backslash before each meta character. So this is forward slash, a backslash here, another backslash. These two forward slashes are escaped. This period backslash, this period backslash, this forward slash, a backslash, backslash and backslash. And there is a full match. You can see here full match. This is a full match. Why? Because we have removed the errors. How? We have put backslashes before every meta character. Hence, if you want to escape a meta character, simply put a backslash before it. Thank you. Hello and welcome to Regular Expression Basics Part 2. In this lecture, we will discuss some more meta characters and their application. In the previous lecture, we discussed 12 basic meta characters with special meanings. But these meta characters are single character meta character. There is another group of meta characters which include a backslash at their start. In fact, two character combination is used as a meta character and they lose their specific behavior when used alone. The backslash in combination with a literal character can create a regex token with some special meaning. So, some meta characters, the single character meta characters, are escaped by using backslash before them. However, some literal characters are made meta characters by using a backslash before them. The first example is backslash d. D is in lowercase. Now this meta character backslash lowercase d will match any decimal digit from 0 to 9. Here, if we use d alone, it will be a literal character and it will match any occurrence of d in your test string. However, if you put a backslash before this d, it will change into a meta character and it will match any decimal digit from 0 to 9. So if you place a backslash before d, it becomes a meta character. Backslash d matches a digit from 0 to 9. So you can see in our test string, backslash d has matched all the digits here. Hence backslash d is a meta character. Backslash uppercase d matches any character other than a decimal digit. So it will match everything, leaving the decimal digits from 0 to 9. If I write here uppercase d, and you can see it has matched the spaces and alphabets and these symbols plus minus parentheses hash etc. and just left the numbers. So you can see that backslash capital D or uppercase D is just opposite to backslash lowercase d, matching anything but numbers. The next meta character is backslash lowercase w. It matches any word character, uppercase from A to Z, lowercase from A to Z, and 0 to 9. The alphabets and numbers are called word characters, so it will match any word character, backslash lowercase w. If I write here backslash w, and you can see it has matched capital, uppercase A to Z, lowercase A to Z, and numbers, but it has left spaces and any other characters. So backslash lowercase w will match from A to Z, upper and lower case, and numbers from 0 to 9. And the meta character backslash capital W, what will it match? Yes, it matches any non-word character, everything other than this, leaving this and matching every other thing. You can see here, if I write here uppercase W, and it has matched every other thing which was left in previous example, the spaces and the symbols etc. It has left alphabets A to Z, upper and lower case, and 0 to 9 the numbers. Every other thing is match. Backslash lowercase s matches any white space character, and backslash capital S matches any non-white space character. Now I put a tab here, 1 2 3 4. Now in this test string there are spaces, there is a tab, etc., and I am going to write backslash s, and backslash s has matched all the spaces and tabs in this text. Technically it matches any white space character. Space is also a character in regex. And what will be the behavior of backslash capital S? Yes, you are right. It will match everything but white space. If I write here like this one, and okay, leaving the space, white space and tabs, etc., and matching every other thing. So here are 6 more meta characters. When used alone, upper and lowercase d, upper and lowercase w, upper and lowercase s are literal characters. But if we use a backslash before them, then this combination only is a meta character, and backslash lowercase d matches decimal digit, backslash lowercase w matches any word character A to Z, upper or lowercase, and 0 to 9, and backslash lowercase s will match any space character. Backslash with uppercase of these letters will match the opposite of what it matched earlier. Thank you. Hello, in this lecture you are going to learn about the dot or period meta character. Dot or period matches all except new line. In regular expressions, the dot or period is one of the most commonly used meta characters. It is also called a wildcard as it will match any character. However, you have to keep in your mind that it is the most widely misused meta character also. So you have to use it with care. The dot matches a single character without caring what that character is. The only exception is line break. Now this is our test string. Here we have uppercase A to Z, lowercase from A to Z, the numbers 0 to 9, and all the special characters which is usually found on a keyboard. And now if I write dot meta character here, and you can see that dot has matched all. So dot matches all except new line. It is not matching new line here. Now what is the meaning of matching new line? Okay, let's see. The last character in first line is uppercase Z, then a new line, then another new line, and then there is A. So you can see after Z there is a continuous matching up to A. So here this line and new line characters are matched with \n, 2 times new line. However, here with dot meta character you can see that the new line character is not matched. This is the exception. Now in this case we have our test string consisting of 5 words: car, tar, jar, par, and far. All of these words are ending in AR, so this is the common AR. As dot matches all but new line, hence if I put a period here, and this is a match for all of these words. Why? Because AR is common in these words and dot means any character. So here it is C, here it is T, here it is J, P, F, and any character means if there is space AR it will be a match. If there is dot AR it will be a match. If it is hash AR it will be a match. If it is plus sign AR it will be a match. So dot means any character. So this regex means any character AR. So dot will match not with alphabets but with symbols or with numbers also. Like 9 AR it will be a match. Sometimes we have file names with numbering and we want to match all files with some common name like file 1, file 2, file 3, file 4, and file 5. So how to match file of this type? Okay, file file dot, it will match all files with these specific numbers. But please keep in mind that dot matches one character. So if I change it to, let's say, 7, it is not a complete match here because dot means one character. It could be any character other than a new line, but it must be one character. Hence file 57 is not a complete match or full match. Usually we have file names with extension like file.txt or file.html, etc. Now let's suppose you want to match files of .txt extension. Now what will be the regex? File.txt. So it is a full match here. Now is this a satisfactory or okay regex for extension? I would say no. Why? Okay, let's see here. File for txt, a match. File hash txt, a match. File space txt, a match. Now, why these are all matches? Because dot means any character, and space is also treated as a character in regex. So 4 is any character, hash is a character, space is a character, hence all of these are matches. Now if you would like to match only file.txt, then what you are going to do, change this dot into a literal character, backslash period txt, and it will match only file.txt. So it is necessary in these cases that you change the behavior of period or dot from meta character to a literal character, so that it should match file.txt and it should not match file space txt, file hash txt, etc. Similarly, if you want to match numbers with decimals like 12.34, 12.34, it is matching this number. However, it will match these terms also: 12q34, 12934, 12 plus 34, 12 multiplied by 34, and 12 minus 34, and 12 divided by 34, etc. So here if you want to match this 12.34, a decimal number with decimal point, simply change the behavior and change it from a meta character to a literal character, means simply a dot. Now it is matching 12.34. If you refresh your memory about modes in regular expression, then I discussed single line mode. I told you it is simply treating your string as a single line, and dot matches new line character. Now our test string is this is a car, and our regular expression is also this is a car. It is a complete match. But if I move it to a new line, this is a car, it is not a match. And if I place dot here, period, it is not a match, because dot does not match new line. But if I change the mode or flag from here to single line, dot matches new line, you can see here it is a complete match, full match. Now dot is matching new line. However, this feature is not supported in Ruby and JavaScript. If I change the modes from single line to, and I remove this flag of dot matches new line, and now it is not a match, and single line, and it is treating your whole test string as a single line. So dot is matching this, because now it is not treating this as multiple line, rather in this mode you treat your whole string as a single line. So this is about dot meta character and about its uses. Thank you. Hello. In this lecture you are going to learn about non-printable characters and how to match them in your regular expressions. So we are going to see meta characters for non-printable characters. You can use special character sequences to put non-printable characters in your regular expression. Two of these, the most important ones, are tab and new line. Tab is represented by \t and new line is represented by \n. The first question is, what is the use of such meta character? Let's see here. The test string is this is a car, and if I write here this is a car and there is no match. This is the same text string and also there is no error, but there is no match. So the printable characters are same. Where would be the difference? In non-printable characters. So non-printable characters are also important. Literal characters are exactly same. This is a car. Now we will look for non-word characters with our \uppercase W. And we come to know that this is a space, this is a space, and this is a tab. And a space will not match a tab. If I write here with space, THIS, this is a car. Now this is a space character and this is a tab character. It will not match it. In order to match this, what we have to do? We have to use \t, and now this is a match. This was the reason that it did not match earlier. Similarly, let's delete this tab from here and make it one space. Now this is a match. But if I move this car to new line here, again it is not a match. It is a match here. This is a space and car, and if I move it to new line, now there is no match. For new line match we have to use \n here. By using \n here, okay, not here, before car, okay, car, and this is \n. When we place \n, new line and car here, so it matches. This is a car and this is new line car, and after car we place a tab which I bought yesterday, and here if I write which I bought yesterday, and there is no match. Why? Because there is a tab before which. We have to place a tab here. So \t is tab, \n is new line, and \v is vertical tab, rather vertical space. Actually some of the flavors treat it as a vertical tab and some of the flavors of Regex treat it as a vertical space. So it depends on the language in which you are working. \r is carriage return and \f is form feed. Now if I move it to down here, yesterday here, and now there is no match, and if I write before yesterday \v, and now again it is a full match. This is how you can use meta characters for non-printable characters in your test string. Thank you. Hello. In this lecture you are going to learn about character sets. A character set is also called a character class. With the help of a character set, you can tell a regex engine to match only one character out of two or more characters in that specific set. The syntax of a character set is that you put square brackets around your character set, one at the start and one at the end. Now here we have a character set, square bracket BC, square bracket close A and T. Now this regex is going to match either B or C with AT, like it will match BAT bat or it will match CAT cat. A character set matches only one character out of that set. Hence it is not going to match BCAT because it is going to pick only one character out of this set. Now here I write a character set, square brackets B, C, close square brackets. This is the character set, and with it I write AT, and it is matching bat as well as cat. When the regex engine sees this text string, it looks for either there is a B or a C. If it is present then it will look for an A and T, and when it finds BAT or CAT, it shows a full match. However, it will not match PAT pat or MAT mat or VAT vat. In fact, it will not match any other character but B or C with AT. Similarly, can you guess this regex will match how many words? In fact, it will match only two words, CAR and JAR, like car and jar. However, it will not match any other word with the AR at the end and any alphabet before that. Why? Because our set contains C and J only, so it is going to pick either C or J with AR and will match those words in our test string. So it is not going to match PAR, TAR, EAR, FAR. These are not matches here. If you want that PAR is a match, should be a match, then write P here. Similarly, you can include T for tar, E for ear, and if you want to match far, you write F here. Now for each of these words, regex is picking only one character out of this character set and then goes for AR. Now this is matching these words but not these 4AR, star AR, hash AR. Now the difference between this character set and a wildcard is that it is matching these English words. But if instead of this character set I put a period here, a meta character, it is matching all these words, and star AR, space AR, because space is the character, and dot matches everything but new line. So if you want to match only the English words which matter to you instead of this rubbish hash AR, etc., what you can do is instead of dot, square bracket CJPTEF, square bracket close. Now this is your character set and AR. It will pick one character from this set and will look for AR and will match these words. The order of alphabets within character set is not important, so we may write FE still will be a match. This is a character set at the beginning of a word. Now we are going to use character set at the end of certain letters. This is our test string: pat, pad, par, pan, and pap. And our character set is TD, so it will match PA if it looks for T. If it is there, it will match it. Similarly, it will look for PA and D. If it is there, it will match. So only T and D will match, and it will not match PAR, PN, PF. If you want to match these words, you include them: PAR, PAN, PAF. You can increase your character set as much as you would like. Even you can write from A to Z there. Similarly, if you want to write regex which would match metal and medal, you can write your regex as ME character class TD character class close and AL. It will look for METAL or it will search for MEDAL. However, it is not going to match METDAL because it will pick one character out of this character class. You can use 2 or more character sets in your regex, just like if you have to match banana and Panama. The regex will be first select BP, ANA, MN character set and A. Now you can see this regex will pick either B or P, one character, immediately followed by ANA, then one character either M or N, and then A. And you can also place numbers inside your character set. Now this is your character set 1, 2 and 7. It will match 1, 7 or it will match 2, 7, but it is not going to match 3, 7 or 4, 7 because it is picking either 1 or 2 and looking for 7. In order to match any year after 2014 up to present year, like 2015, 2016, 2017 and 2018, what should be the regex for that? 201 character set, and it should be 5, 6, 7 and 8 and close character set. So it will match all the years after 2014 up to present, and it is not going to match 2013 or 2019 etc. 201, and it will look for either 5 or 6 or 7 or 8. Hello. In this lecture you are going to learn about a character range. It represents a series of characters. You can use a hyphen inside a character class or character set to specify a range of characters. The syntax is square bracket, that is start of character set, then the start character, hyphen, and then the end character, square bracket close. Hyphen is used for range inside character set. However, outside a character set, hyphen is a literal character. If the regex is a hyphen z, it will match three characters a hyphen and z. Now first let's see an example. Here we have these sentences in the test string. A is an alphabet, B is an alphabet, up to E is an alphabet. And if we want to match all these five, what we can do, we can say first a character set A, B, C, D, E is an alphabet. Now all of these sentences are now full match. Now at a time only one character from this character set will be selected, and this is common, is an alphabet. So for first line A is an alphabet, for second line it will select match B is an alphabet, and for last line similarly it will match E is an alphabet. If I write here F is an alphabet, so it won't be a match because here the character set only contains 5 alphabets from A to E. Now A to E is a series, and what we can do is, instead of writing all these 5 alphabets, we can write from A to E a series. And here this is a character range. From A to E is the character range, and is an alphabet. So wherever it will find A, B, C, D or E, it will match in the test string, and then it will search for space, is, space, and space alphabet. So this is just making your life simple and easy. You might say that we can write from A to E, but let's suppose you have more strings like this one. Now if the test string is like this one, F, G, H, I, J, K up to Z is an alphabet, and let's suppose there are other test strings here and you want to meet them. Now what you will have to do, write entire A to Z here. So you can write from A to Z in lowercase and is an alphabet, and it will match all these sentences. But to make it simple, what we can do, we can simply create a character range, and now from A to Z is an alphabet will match all of these sentences. Now it is not like that the series always start from A and goes up to Z. You can form any series like from D to G. Now it will match D, E, F and G is an alphabet. You can construct series of your choice and what is your requirement, depending on what is your requirement. Similarly, another series could be from D to G and from K to Z. So it will match any character, one at a time, of course, only one single character, and it will match with is an alphabet. So K to Z is a range and is an alphabet. If I write here X, or if I write here A, ZA is an alphabet, it will not match here. Character range is case sensitive. That means if you write here from A to Z, it is a complete match. But if you write here from capital A, uppercase A to uppercase Z, and not a single match. Why? Because character range is case sensitive. Now if our test string is like A is an alphabet, B is an alphabet, C is an alphabet, A, B, C are capital or uppercase, however D and E is in lowercase. So capital A to Z range will only match capital A, B, C or any character from A to Z. Now if you want to match the lowercase, you can add here another range, lowercase a hyphen lowercase c. Now here inside this character set there are two ranges, A to Z uppercase and A to Z lowercase. Similarly, the character string 0 to 9, this is a range, character range, is going to match any number from 0 to 9. If you want to match numbers in the range of 0 to 5, you can change it from 0 to 9 and change it to 0 to 5, and it will match any number numerical values from 0 up to 5 instead of 9. So 0 to 9 means matching any character of numerical status from 0 to 9, or a number, decimal number. Now if you have to match these files like file 1, file 2, file 3, 4 and 5, what you can do, the simplest solution that comes to one's mind is file asterisk dot or period, file dot or period. Now but that will match not only these files, but that will match also file hash, file space, file dollar, file plus, file percent sign. So what we can do, file character range and 1 2 3 4 5. Okay, it will match only these files, and instead of 1 2 3 4 5 we can change into a series 1 2 5, and it will match only these files, and it will never match file hash, file space, file dollar, etc. The regex engine will match file and one character out of this character set. It will look for file 1, file 2, file 3, file 4, file 5. However, it is not going to match file 6 or file 7, etc. And if you want to match these, what you can do, you can move it to 9. Now the series is from 1 to 9. You can change the start or end of series from 5 to 9, from 5 to 7. You can see the change in match information. The matches will change accordingly as you will change the series here. Now let's suppose you want to match any year after 2014 up to present year 2018. What you can do, 201 character set contains 5 to 8, because after 2014 means starting from 5 and current year is 8. So it will match all the years after 2014 up to present. However, it will not match 2019 or 2020, etc. So in this way we can set the range in our regex. Well, earlier I discussed about two series in one set. You can add numerical values in it also. So uppercase A to Z, lowercase a to Z and 0 to 9. Now it is going to match any alphabet, uppercase or lowercase, and any numerical character. So but it is not going to match other characters like these, or special characters like these. However, it is going to match A to Z, upper and lower case, and any number from 0 to 9. Now hyphen is used for range inside character set. However, outside a character set, hyphen is a literal character. Like A hyphen Z will match 3 characters, A hyphen and Z only. Now when hyphen is used inside a character set, it is for range. A hyphen Z means from A to Z, any character. So it is matching A and Z, not hyphen, and from A to Z, any character. However, if it is written outside this character class, A hyphen Z, then it literally means A hyphen and Z. Now hyphen is a literal character here outside character class. Now a brief summary of character range. A to Z will match any uppercase alphabet. Lowercase a to Z will match any lowercase alphabet. 0 to 9 will match any number from 0 to 9. So this is all about character range. Thank you. Hello, in this lecture you are going to learn about negating a character set or not matching a specific character set. Using a caret after the opening square bracket of a character set negates the character set. Now the character class matches any character that is not in the character set. Now here in our test string, lowercase alphabets from A to K, and our character set is A, B, C, D. So it will match any character, one character out of A, B, C, D at one time, of course. Now if I write a caret here just after the opening square bracket, it will negate this character set. As a result, it will match anything but A, B, C, D, and in anything comes even the space. It has matched this space. It will match uppercase A, B, C, D, E, F. It will match special characters, etc. In fact, everything. But it will leave A, B, C, D and will match A, tab, B, C, and then backslash, forward slash, anything, any character, even if it is a space character, tab, but it will leave A, B, C, D. Now as you know, a character set of lowercase a hyphen lowercase z will match lowercase letters in your test string from A to Z. And if we want to negate that, we will put a caret after the opening square bracket, and it will match anything but lowercase a to z. It will match uppercase A to Z, it will match all the numbers, it will match spaces, it will match special characters, it will match everything, but it will leave lowercase A to Z alphabets. Similarly, this character set 0, 1, 2, 3 will match 0, 1, 2, 3. However, if we negate it, it will match anything but 0, 1, 2, 3. If I use range here 0 to 9 and don't use a caret, 0 to 9, it means it will match any number, any digit. And if I use caret here, it will make the selection or matching opposite. 0 to 9 means matching any number, and caret, negating the character set, it will match everything, leaving numbers from 0 to 9. I hope now you get the idea of how to negate a character set or character class, and what is the meaning of that, what is the idea and philosophy behind that, how we do it. Now this is our test string car, jar, par, far, and year, all ending in AR, so AR, and within character set I have written C and J, so it will match CAR or JAR, car and jar. So it has matched car and jar, and it has left PAR, FAR, EAR and everything other than CAR and JAR. If we negate it, it will do opposite. Correct CJ, it will leave CAR and JAR, and it will match any other word with AR, like ZAR, OKR match, 9AR, OKR match, but please keep in mind it is not going to match any other pattern, like PER, no match, TER, no match, etc. TAR, yes, it is a match. So AR is there. It will leave CJ and it will pick any other character, immediately followed by A, immediately followed by R. And if it finds that, it will show a full match. Here CJ character set AR means I want to match this set CAR or JAR. I want to match this set. And with caret, it means I don't want to match this set CAR and JAR. I want to match any character that is not C or J with AR. Or simply it means do not match CAR or JAR, else match any character plus AR. Now if you want to match any word starting with a vowel, that is A, E, I, O, U, the character set will be like square bracket A, E, I, O, U, square bracket close, and then the remaining part of the word. And if you want to match words starting with consonant, that is the words that don't start with a vowel, what you do, you use a caret here, and now it will match all words that don't start with a vowel. Now here in this regex file, character class 1 to 3 will match file with either 1 or 2 or 3, one character at a time. So it will match file 1, file 2 or file 3. It will pick file and then look for either it is 1 or 2 or 3. Okay, it is 1, full match. It is not 1, it is 2, full match. File 1, no, 2, no, 3, full match. Okay, then file, okay, here it is file, and from this character set no match. Okay, leaving 4, 5, 6, 7, 8 and 9. So this is character set 1 to 3, and by negating it, it will do, now it will leave this selection file 1, file 2, file 3, and it will leave any other combination file with any character, file with asterisk, file with $, even file with space, file with tab, file anything but 1, 2, 3. A negated character class must match a character A square bracket caret B square bracket close. It does not mean A not followed by B. It means A followed by any character but B. Okay, this was our lecture about negating a character class. Thank you. Hello, in this lecture you are going to learn about meta characters inside a character set. We have studied 12 basic meta characters, the characters which have special meanings instead of their literal meaning, and they will not result in a literal match unless they are escaped with a backslash before them. Here is a list of normal meta characters. That means they have special behavior in normal regex. Now we come towards meta characters inside character set. Now there are only 4 meta characters inside a character set: hyphen, caret, backslash and closing square bracket. All other meta characters are simply literal characters within a character set. It simply means that hyphen, caret, backslash and square brackets, they have special meaning instead of their literal meaning, and if you want to take them as literal character, you will have to escape by a backslash or place them at a special position where they do not take their special meaning. All other meta characters, you don't need to escape them with a backslash because they are just literal characters. Please keep in mind that you can escape all the 12 basic meta characters in a character class by using a backslash before them, but it will make your regex complex, reducing readability and comprehension. However, your regex will be fine. To escape a hyphen, we can use either a backslash or placing it at specific position. Now what is that position, or what are these positions? Number 1, placing it right after the opening bracket. Okay, here backslash hyphen, first case. Now placing it right after the opening bracket, it will match hyphen or a, or right before the closing bracket, just like this. Right before the closing bracket, it will match again a or a hyphen, or you can place it right after the negating caret. Now this will match any character that is not a hyphen or b. So these are the cases to escape hyphen. Now second is how to escape a caret. You can see placing a caret inside character set is a pattern error. The first thing is of course using a backslash. Now it is a literal character and this is a literal match caret. Using a backslash just before a caret. And you can also escape it by placing it anywhere except right after the opening bracket. So don't place it after this opening bracket and place it anywhere else like B and next is caret. So it will mean match B or caret, or A, B, C, caret. It will mean match A or B or C or caret. So for escaping caret, either use a backslash or place it anywhere except right after the opening bracket. Now how to escape a backslash meta character and make it a literal character? Only using backslash is a pattern error. Now this backslash meta character can be escaped by using a backslash before it, and it will be a match. So backslash and it is A will match backslash or A. This first backslash is for escaping and second backslash now is for literal backslash. And in the end, how to escape a closing square bracket meta character, the first option is use a backslash before it, and it will be a little character just like this one, or place it right after the opening square bracket. It will be a literal character. You can see a match here. Now this character set means match closing square bracket or A, or place it right after the negating character. Now this regex this character set matches every character that is not a closing bracket or D. So you can see here closing bracket and D are not matched, and every other thing is matched here. If you face issues in some specific flavor of regex, just escape closing square bracket with a backslash. In fact, if you face issues regarding any of the meta characters, just use a backslash, and in most cases it will serve the purpose and will make the meta character into a literal character. This is all about meta characters inside character set and how to escape them. Thank you. Hello and welcome to shorthand character sets. Some of the character sets are used often. That's why there are shorthand meta characters to represent these character sets. As we have discussed that this range from 0 to 9 is going to select any number in your test string. So you can see here square bracket shows it is a set or a class, and 0 to 9 is range, and it is selecting all the numbers in your test string. It is leaving alphabets and it is leaving special characters. Instead of this character range, you can simply write backslash lowercase d. Backslash lowercase d will select any number in your test string. Here you can see in explanation, backslash d matches a digit equal to square bracket 0 to 9 range square bracket close. So instead of writing this range square bracket 0 to 9 square bracket close, you can simply write backslash lowercase d, and it is shorthand for this character set. However, backslash capital D is negation of this set backslash lowercase d. It simply means select everything but numbers from 0 to 9. So it will leave 0 to 9, any number from 0 to 9 range, and will select every other character in your test string. You can see here backslash capital D, it is leaving the numbers and it is selecting every other thing, either alphabets, upper or lowercase, special characters, space, tab, etc. So backslash capital D matches any character that's not a digit equal to caret 0 to 9. Caret is here for negation, means simply don't select this, don't match this range, match everything else. Now backslash lowercase s is going to select white space like tab, new line, or backslash r, backslash f, backslash v. And backslash uppercase s is a negation of this character set backslash lowercase s. Here you can see backslash lowercase s is matching these spaces, and either single space or tab, etc. Explanation, backslash s lowercase s matches any white space character equal to backslash r, backslash n, backslash t, backslash f, and backslash v. However, if we change it to uppercase s, now it will not select the space character, but it will match everything else. It is a negation of backslash lowercase s. So it matches any non-white space character. Next is shorthand for word character, which is backslash lowercase w, and it matches any lowercase or uppercase English alphabets, any number from 0 to 9, and underscore. That here it is matching alphabets, upper and lower case, numbers 0 through 9, and underscore, and it leaves every other character. Backslash lowercase w matches any word character equal to lowercase a to z, uppercase a to z, 0 to 9, and underscore. While backslash capital W, it matches everything other than alphabets, upper and lower case, numbers 0 through 9, and underscore, because it is of course a negation of shorthand character sets backslash lowercase w. So it is negation of this character set or this shorthand character class. So it is caret, backslash, and lowercase w. Hello. In this lecture you are going to learn repetition with quantifiers. Actually, with quantifier you tell Regex engine how many instances of previous element, which could be a character or a group or a character class, must be present in the test string for a match to occur. The three basic quantifiers are question mark, asterisk and plus sign. Now question mark matches the previous element 0 or 1 time. It makes the previous element optional. The previous element could be a character, a group or a character set. Asterisk matches the previous element 0 or more times, and plus sign matches the previous element 1 or more times. Okay, the first one is a question mark. As I have told you, a question mark makes the preceding element in the regular expression optional. Now let's suppose you have to match color. These both spellings are correct and acceptable. Now if you want to match color, color, it will only match this color here, and if you want to match this color, it will be color. However, it will not match this color. From the spellings you can see that this U is optional, so we make it optional U. After U we write a question mark meta character, which makes this U optional. As a result, this regex colou question mark R will match color and color. You can see here in the explanation, a question mark matches the previous element 0 or 1 time, not more than 1, only 0 or 1 time. So if we see here U, either it should be 0 or 1 time only, not more than that. Similarly, for esophagus, these two spellings are correct and acceptable. With O, ESOPHAGUS, and with ESOPHAGUS. Now here O is optional, so what we can do is make this O optional, and it will match both these spellings. Actually, the first one is British spelling and second one is American spelling for the same thing. Now some places for the month of January, the spelling used are January, January, and at some places it is just simply Jan for January, shorthand used for January. So how to match both these? Now Jan is common and UARY is optional. So what you can do is Jan is common, UARY is optional. So making a group of this UARY and making this whole group optional. Now this regex will match Jan UARY as well as Jan. Similarly, you can do this with all the months and days of a week. With days of a week, here you can see a brief short example: MONDAY Monday and MON, and DAY is made optional here, keeping a group of DAY and keep making it optional by this question mark. So MON parenthesis DAY parenthesis question mark, this regex will match this Monday and this MON. Now dates can be written in variety of form, like August 22nd or August 22nd but without ND, August 22, or with a shorthand of AUG and 22 and the 22nd or August 22nd. Now you have to write a regex that could meet all of these dates. So what you could do is first write the full date AUGUST August and 22nd. Of course it will match only this one. Now first the common things in all these four, and the common thing is AUG. UST is optional, so we make it optional. UST is optional, so it matches these two. Now 22 and 22 ND, so we make ND also optional, and it will match all of these four dates here. Here you can see we have made two groups optional. However, we have succeeded in matching all these dates here. Now the second quantifier is asterisk, which matches the previous element 0 or more times. The simplest hypothetical example would be if you have to match these words O, OH, O, double H, and 4 times and about 7-8 times H. Now you will write O, H, and after H you will write asterisk. Now this asterisk will match H 0 or more times. So here H is 0 times, here 1 time, 2 times, 4 times, and multiple times. When we use this meta character multiplication sign or asterisk with any character, it or a group or a class, it makes that character, the preceding character, to match 0 or more times. Here it is H is 0 time, and here it is in more times match. Similarly, if you want to match 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, what you can do is for these numbers \d, and using asterisk would mean matching from 0 to any number of times, so it will match all these numbers. Similarly here, these are our words. One word, test string contains 2 word, 3 word, and 6 times 4 word and word. Here there is no digit, so what we can do is word is common, and before word are digit, and this digit 0 or more times. Now \d asterisk word is matching all these, because \d asterisk means this quantifier multiplication sign will match \d 0 or more times. Here it is 0 time, here it is 1 time, 2 time, 3 times, 6 time. So all of these are complete match. A more practical case would be that we have files, file.php, file1.php, a number with file, file123.php, file45.php, and we have to write a regex which matches all of these sort of files. So the common here is file \d and asterisk any number of either there is 0 number or 1 or more, and after that we have to match this literal dots for literal dot /php. Now this regex is matching all these strings, these lines or these file names. This \d is for decimal number, asterisk is for 0 or more matches, and this / is here to make this period a literal character. And now the third quantifier plus meta character matches the previous element 1 or more times. It is similar to asterisk, but it matches the previous element 1 or more times, so it will not go for a 0 match. So if you see the example here with asterisk, it is matching 0 or more times. If I write here plus sign, now it is matching at least one time or more. So it is not matching O, but one edge or more than one edge. It is a complete full match for these four. Similarly, with backslash d asterisk, it is matching all these. Even there is no decimal number here, this is a match. By converting this one from multiplication to plus, it will match at least one number plus WORD. So it is not going to match WORD. And here, if the regex is changed from asterisk meta character to plus, it is going to match file plus at least one decimal number, one digit, and dot php. So it is not going to match file.php. If I write any number here 9, it is going to match. If I write here multiple 9, it is going to match. However, if I remove all the numbers, because this backslash d plus sign is making the number should match if it exists one or more times. If it is 0 times, it will not result in a match. In this lecture, you have learned about the use of quantifiers question mark, asterisk, and plus. Thank you. Hello and welcome to Limiting the Repetition lecture. In this lecture you are going to learn how you can control the repetition with a pair of braces, opening braces and closing braces. These are of course meta characters. Now the first case is opening brace n and a closing brace. Now explanation is this matches the previous element exactly n times. And the example here is \d, opening brace 3 and closing brace. It simply means match any number consisting of 3 digits, not less than 3, not more than 3, and hence it will match 1 2 3 4 5 6 9 1 1 because all the numbers are 3-digit numbers. However, it will not match 1 1 2 3 5 6 7 1 0 0 7 or 9 because this is a 2, this is a 5, this is a 4 and this is 1-digit number. So you can see here \d 3 within braces is matching these 3 numbers. These are full match, and this regex is not matching this. If you want to see a complete match, then what you can do is use word boundaries before and after your main regex structure. Use \p. Now you can see that it's matching these 3 numbers. We are going to discuss word boundaries in later lectures. The second case is braces minimum, comma and close. This structure matches the previous element at least n times, and it will match more than n times but not less than n times. So a simple example would be \d brace 2 comma close bracket will match 1 2 1 2 3 4 5 6 7 because all these numbers are at least 2-digit number or more than 2-digit. But it will not match 1 4 9 because these 3 numbers are single digit. So this is the minimum requirement of repetition of this structure or this element. Here this number is exact repetition of this element. Here this is the minimum repetition of this element. Here testing this regular expression \d means a digit and it should be repeated a minimum of 2 times and more. So any number consisting of 2 or more digits will be a match. Here 1 2 1 2 3 4 5 6 7, these 3 numbers are 2 or more digits, so these are match. However, 1 4 9 is not a full match, is not a match because it is less than 2, and we have quantified here the repetition at least 2 times of this structure. Now let's suppose you have salaries of hundreds or several thousands of individuals, or how much people earn in 1 month, and you want to see how many people are earning in 6 digits. So what you can do is minimum of 6, and now you can see that these many number of people are earning 6 digit. However, 1 2 3 4 digit, 1 2 3 4 5 digit, these are not match. So in this way you can see the minimum number of times a match would occur. And the last one is minimum comma maximum. It matches at least n times but no more than m times. So \d 3 comma 5 brace within braces, it will match any number which is at least 3 digit and at maximum 5 digits. So 1 2 3 3 digit, it will be a match. 4 5 6 7 4 digit, it will be a match. 1 4 7 2 5 digit number, it will be a match. However, 1 which is less than the minimum will not be a match. 7 1 digit, no match. 2 2 less than 3 digit, no match. 1 2 3 4 5 6 digit number which is more than maximum will not be a match. And 7 8 7 8 7 8 9 9, 8 digit number will be not a match because it is more than the maximum limit here. Now in this example you can clearly see the numbers having at least 2 digits and at maximum 5 digits are a full match. However, less than 2 digits like this one 1 and more than 5 digit number like this one and this one, these are more than these numbers contain more than 5 digits, so these are not a match. So this is how you can control repetition. This is the minimum amount of repetition of this backslash t, and this is the maximum amount of repetition of backslash t. Please keep in mind that in place of d there could be any character or a character set or a group of course. Thank you. Hello, in this lecture you are going to learn about greedy and lazy regular expressions. A greedy regular expression matches the previous element as many times as possible. Greedy means match longest possible string. It means your regex will match as long group as possible. However, a lazy regular expression matches the previous element as few times as possible. Lazy matches the shortest possible string. Now here is an example. Let's suppose you want to use a regular expression to match an HTML tag and you are passing HTML file. Anything in between sharp brackets is of course HTML tag. Now if you like to match HTML tag, you write yes, this sharp bracket, then dot means valid, character, wildcard character plus, and close bracket. Now you would have thought that it would match this tag and the opening h1 tag and the closing h1 tag, but it has matched the whole string including this heading written outside these brackets. Now why is this? What is the reason? The reason is because this plus quantifier is greedy by nature, as the question mark, plus or asterisk, all these three quantifiers or meta characters are by default greedy. Now let's see how this works and what is the meaning of being a greedy. The first token in the regular expression is less than sign or this bracket. This is a literal of course, and the regex engine will try to match it in the string and it will find it at the first place. Now after that the first token is a period or dot, which means a wildcard or any character except new line of course, and the dot is repeated by the plus, and plus means one or more time. This plus is greedy here. As a result, the engine will repeat the dot as many times as it can. The dot matches h, so the regex continues to try to match the dot with the next character 1, which is of course also a match. After 1, the next character is greater than, and greater than is also a character, so the dot matches this character, and then it moves on to h, a literal character, e, a literal character, similarly a, d, I, n, g. So it moves up to g, and all are matches here. Let me include one more word here. Okay, and after that it will look for this, and for dot it will be a match, / match, because dot matches everything except new line. H is a match, 1 is a match, and this dot is repeated by this plus sign, and this greater than sign is also a match. Then space is also a match. It will move on to capital E will be a match, N will be a match, and D will be a match. Now after that the string ends here, and this regex dot plus sign matches up to here, up to D, and after D this is the end of string. After that it looks for this sign or greater than sign, and this sign at the end of this string, of course it does not match here at this place. Now the regular expression engine remembers that the plus has repeated the dot more often than is required. And of course, the plus quantifier requires the dot to match only once. Now the regex engine will backtrack from here, and it will search for this sign, this greater than sign. So it will see D, no. In the reverse order, N, is this a match? No. E, is this a match? No. Space, is this a match? No. Okay, this sign and this sign, yes, of course, this is a match. And when this is a match, the regex engine reports that this string, this part of string, is a full match here. Please remember that the regex engine is eager to return the match. It will not continue backtracking further to see if there is another possible match. It will report the first valid match it finds. Because of greediness, this is the leftmost longest match. So the summary, this less than sign matches with this less than sign plus any character, and a dot plus means a literal character and repeated at least one time, and up to as many times as possible. It will match up to here D, and at D it will search for this sign greater than, and not finding here, it will backtrack, and when it will backtrack, it will match at the first instance, and it will match here, and it will return this string. Similarly, in this test string, I like moon and stars as they are amazing, and here, now here, inverted commas, then dot plus and inverted commas. One would like to match all those within the inverted commas, but this regular expression has matched the words inside inverted commas as well as these outside inverted commas. Now the reason this inverted comma tries to match with this one, and goes up to here, and it starts a match. After that, this dot and plus repeated as many times as possible keeps on matching and moves up to end of line. At here, now it goes for the next token, which is inverted commas close or inverted commas. At here, it does not find this, and it backtracks and keeps on searching until unless it finds this inverted comma. As soon as it finds inverted comma here, it registers a match. Similarly, the question mark and asterisk, these quantifiers, when they are used, are by default greedy. That means they match the previous element as many times as possible. Thank you. Hello, in this lecture you are going to learn about the lazy behavior of regular expression, how you can make a certain behavior lazy, because the greedy can sometimes or many a times can be a problem. For example, out of hundreds of tags, you want to match the tags and it matches the string or the text inside these tags, or you want to match the words in between inverted commas and it matches the text outside inverted commas. A fix to this problem is to make the plus lazy instead of greedy. Lazy quantifiers are also called as ungreedy or reluctant, and this can be done very easily. Simply put a question mark after the quantifier. So you can put the question mark after the plus sign or question mark itself after question mark, another question mark, or after the asterisk, and it will mean match as few times as possible. Now here in this case, after plus sign quantifier I put a question mark, and now this regex has become lazy. Instead of selecting this text or matching this text, it is only matching these tags. Now in case of some more tags here, so less than, dot, plus and greater than sign, and it is matching this whole string including tags and text written in between tags, etc. So if you want to select only, match only tags, put a question mark here, and it has become lazy now. The behavior is lazy now, and it has selected all the tags out of this text. Now how does this work? A brief explanation. In this regex, the less than sign matches with the first less than in the string. This matches with this less than here. After that there is a dot and the quantifier is plus. That means match one or more time, and this plus is repeated by, is followed by question mark. That means this plus is a lazy plus, so it means match at least one time, but few possible times as possible. Simply this tells the regex engine to repeat the dot as few times as possible. The minimum is 1, of course. So the dot matches with capital H and the requirement is fulfilled. Now the regex engine moves on to this character is greater than and matches this greater than with this 1, and as this is not a match, this fails. Again the engine will backtrack, but this time the backtracking will force the lazy plus to expand rather than reduce its search. So the match of dot plus is expanded to h1, and dot matches with 1, and again it says okay, this is the now fewest possible. Now it goes for this greater than and matches with this bracket and this greater than sign, and it is a match. So this, it registers one full match. So it matches the first character and then moves on to the next, and if it isn't a match, it backtracks there and expands this dot plus, and it is matching the fewest possible as in the test string. Similarly here, if we put question mark here, now only the words in between inverted commas are full match. This is how we can make our regex lazy instead of being greedy. You can also use a negated character class to show this lazy behavior. It brings efficiency, saves time. for the regex engine, and CPU cycles are saved and your code becomes fast. Now how it is done? Just create a negated character class, like here this is start of character class, this is end of character class, and in this class negation of this bracket, and after that we write plus quantifier. Now you can see here again these brackets are, these tags are complete match. This negated character class is simply saying match any other character but this sign greater than sign. So plus is repeated one or more times, and the time here is 8 steps and 0 millisecond. And here in case of previous regex there are 11 steps, 3 more steps, but this is just simply one line of code, and you may have hundreds of lines of code when you are passing HTML of a large web page. Similarly here, negated character class, negate, and close bracket, and then plus sign here, and these inverted commas. Okay, now same two words are selected or matched which are using inverted commas, and this character class says match any character but inverted commas, and keep on repeating, and when there is inverted commas stop repetition and move on to the next token or next character here in regex, which is inverted comma, and it will be a complete match. You can see in normal case there are 15 steps to make it lazy, and in negation with character class now of course yes 8 steps, so these steps are reduced. So this is about greedy and lazy expressions. Quantifiers are greedy by default, and if you want to make them lazy, use question mark after the quantifier, or simply use a negated character class, which is of course to use a negated character class is a better option. Thank you. Hello. In this lecture you are going to learn anchors in regular expression for a start and end of string or line. Up to now we have studied about literal characters, meta characters, dot, etc. And putting one of these in a regex tells the regex engine to try to match a single character at a time. Anchors are totally different. They do not match any character at all. Instead, they match a position before, after, or between characters. Actually, they are used to anchor the regex match at a certain position. The caret matches the position before the first character in the string, while a $sign matches right after the last character in the string. So the idea is very simple. Let's check it. As you know, \w word meta character, and we use plus sign, so it has matched all the individual words here. This is the car which I saw yesterday, and 4 plus 4, 8 matches. You can see here full 8 matches. Now if you want to see the first character, if you want to match the first word in your at the beginning of your line of text, if you put a caret here, it will match the first word, this, because this caret ensures that the match occurs at the beginning of the line. Similarly, for the end of line match, put a $sign here and it matches the last word here. \w plus is a full word, and $sign means at the end of your string or at the end of line. Now this caret t will match this t because it is at the beginning of this test string. However, caret r does not match here because r is not at the beginning of the string. Similarly, caret t, no match, but caret t, it is at the beginning of string, hence it is a match. Similarly with t $sign, t is not at the end of string, it is not a match. R, no match. E, yes, it is a match because E is at the end of string. Now if you want to see if your string starts with a number, caret and \d, and it is a match. The string is starting with a number. And if you want to see if your string ends with a period, what you can do, literal dot and $sign. So full match, that means there is a period or full stop or dot at the end of your string. It is usually good if you are working with caret and $. You use multi-line mode while working with these, so that you have matches throughout your string if it is multi-line. So this is all about anchoring about the beginning of string or line or end of string or line. Thank you. Hello, in this lecture you are going to learn about word boundaries. The meta character \b is another anchor, just like caret or the $sign. It matches at a position that is called a word boundary. Actually, the condition is that the match must occur on a boundary between a \lowercase w alphanumeric and a \W non-alphanumeric character. Now, if you could remember, \lowercase w means character set of lowercase a to z, uppercase a to z, 0 to 9 numbers and underscore. And \W means negation of \lowercase w. That means any character other than lowercase uppercase a to z, 0 to 9 and underscore. There is another meta character \B, which is technically negation of this \B. The match must not occur on a \B boundary. However, mostly \lowercase b is used. Now, technically there are three such positions. Number one, before the first character in the string, if it is a word character, of course. Number two, after the last character in the string, if it is a word character, that is also a boundary. Between two characters in the string, where one is a word character and the other is not a word character. So technically there is a match between a \W alphanumeric and a \W non-alphanumeric character. Now, in this test string, let's suppose you want to match car. If you write here car, it will match this is a car, it is my car, it is a good car. He is watching cartoon, and this is a match here, or it is pointing out car out of cartoon. Now, if you want to match full word car, what you can do simply is \B. Okay, still all are four matches. Cartoon, car out of cartoon. Now you want to end after R \B boundary. You want to create a boundary after car. So now it will match these three car, but it will not match car out of cartoon. Here, what have you done? You have created a word boundary. Simply putting \B actually allows you to perform a whole words only search using a regex. It is usually in the form of \B, the word, and \B. Since digits are considered to be word characters, hence \B can be used to match a particular number that is not a part of a larger number. Just look at these numbers, and if you want to match 2, 3, now it is matching 2, 3 in almost all the numbers. And if you want to match exactly 2, 3, now what you can do is form a boundary here and a boundary here. Now it will match only 2, 3. So saying that \B matches before and after an alphanumeric sequence is more exact than saying before and after a word. Now let's suppose you want to match any 4-letter words in your test string. Now here, to match any 4-letter word, what you can do is \W and quantify it to 4. Okay. Now using word boundary, \W and a \W here. So here you get all the 4-letter words in your test string. But there is a question: will it only match 4-letter English alphabet, or it will match something else like TIE4? Okay, this is a match, but you want English words. What you can do is, instead of \W, use a character class. So now you can see here that TIE4 is not a match here. Why? Because the character class contains only English alphabets, lowercase and uppercase, and the quantifier is braces with 4, that means any 4-letter word. As \w consists of A to Z upper and lowercase, 0 to 9 and underscore. So let's suppose you want to match words starting with a vowel, that means A, E, I, O, U. Now here are the two boundaries in between character class A, E, I, O, U, and this ensures the word starts with a vowel, and after that A to Z and star, quantify 0 or more. Now this will match a single character starting with vowel or a word starting with a vowel. If you want that you have only word match, what you can do is instead of this star, 0 or many, you can change it to at least one more word, one more character here. So it is matching AT, apple, and an egg, but it is not matching A here. If you want to match A here, you just change it to star and it will match A, because star means 0 or more of this group, and plus means at least one or more of this character class. Now let's suppose you want to match all those words which are not starting with a vowel. What you can do? Well, very simple. You will just negate here this character class and with caret, and the match is, well, a strange one because it is matching space here. Now you should also negate the space included in this character class, and now you can see these are all the words not starting with a vowel. That means these are all the words not starting with A, E, I, O, U. So this is how you can match words with word boundaries, but instead of \w, use character class of A to Z. It will not match numbers from 0 to 9, and it will not match underscore. And well, \b, capital B, uppercase B produces results just opposite to \lowercase b. You can see here \uppercase b, \w plus, and \uppercase b. So strange sort of leaving the first and last character of a word and selecting the central portion. Hello and welcome. In this lecture you are going to learn about groups in regular expressions. For groups we use parentheses and the syntax is opening parenthesis, group and closing parenthesis. By grouping characters into a group you may apply a quantifier to the entire group or to restrict alternation to that part of regex. We are going to discuss alternation in the next lecture. However, only parentheses can be used for grouping. Square brackets or braces cannot be used for grouping. And you may also create a numbered group and use it later. Now, possible or impossible for you, you have to do it. This is our test string, and let's suppose you have to match possible and impossible, either one or both these here, and you have to match them. Now impossible, by placing parentheses around impossible, now this im becomes a group, and after forming this group we have placed a quantifier question mark which makes this group optional. Hence this regex will match possible, the word possible, and also impossible. Why? Because this im is optional. If it is there it will match it, if it is not there it will match only possible. So this regex is going to match possible as well as impossible. Now to understand groups better, let's see these phone numbers, and we have to write regex for these phone numbers. So the regex would be \t and 3 times, then hyphen \d, this \d for these digits and these are repeated 3 times, then hyphen, then again \d and these 3 numbers, so that means digit repeating 3 times, another hyphen and \d and repeating 4 times. Now this regex is going to match 4 numbers written in this format. When this regex matches these two phone numbers, this is called group 1. This whole regex is called group, not group 1, rather group 0. This whole regex is called group 0. So the full match is group 0. If we put parentheses around this one, it will be called a separate group and it will be named group 1. If I write up to here another parenthesis here and here, this will be group 2. From left to right it will start naming groups. The whole regular expression is group 0, this is group 1, and this is group 2. You can see it here, match information group 1 4 5 6 and group 2 1 2 3 4. Similarly group 1 4 5 6, group 2 7 8 9 0, and you can see it is naming from left to right the groups. And if you want to refer any group in your regex, like this is group 1, this is group 2, if you want to refer this group you write this hyphen / and group number 1, so it is a complete match. Group 1 means this one \d and 3 times repeating, and this is group number 1, so it is matching only this one. So you can refer a group in your regex with / and group number. Now you see here a practical example of group and then using that name group. Let's suppose you want to see repeated words in your text and you want to isolate them. Now first you write a boundary \w word character plus and \b. This is going to select all the words here. Now after every word there is space, one or more. Okay, Now this is like that, and we want to see either this word is repeated or not, so we make it a group like this one, backslash w plus, and putting parentheses around it. Now this is a group, and we want to see either it is repeated or not, so we write here backslash and 1. This whole match is group 0 and backslash w plus is group 1. When we write here backslash 1, it means that to check this word is repeated after some space, and yes, these words are repeated here. In this way you can see if there are any instances of words being repeated in your text. I hope the idea of numbering a group is clear with this example. Please keep in mind that you can group a character set, but you cannot use groups within character sets. Another example, let's suppose you want to match any word that starts with PLAY and later it has any number of characters like play or player or played or playing, etc. So PLAY is compulsory, so you want to see for certain words that start with PLAY. So the regex will be PLAY, and next anything backslash w plus, and that is optional. So here this is our group and this group is optional, hence it will match play or anything play with any word character. If you don't want to add numbers, then use a character class like this one. Yes, because backslash w plus will match words like play 1 2 e z, and this will only match qualified English words. So this is introduction to groups. Thank you. Hello, in this lecture you are going to learn about alternation in regular expression. Alternation is done with vertical bar or pipe symbol. Alternation is just similar to character class in behavior. As I told you that you can use character class to match a single character out of several possible characters. Similarly, alternation can do the same, but its scope is much more. You can use alternation to match a single regular expression out of several possible regular expressions. Now let's say if you want to match gray gray and gray gray. Both spellings are acceptable and correct, of course. Earlier we could have done it like gr character class AE. The engine will pick any character out of this character class, one character, and y. So this will match gray and grey. Now with alternation, what we have to do is gr and y is common and a and e are different in both these words. So what we can do is use parentheses to form this a group and use this pipe for A and E. It simply says that the regex engine has a choice to match either A or E. But please keep in mind that the regex engine is eager. So in case A matches, it will stop matching further. Hence the position in alternation is important. Similarly, there are cases when you want to match either regex.com, any website.com, or regex.net, any website with .net extension. You want to match either .com or .net extension. What you can do is you can write regex / a literal dot, and use alternation, and this is for or choice, and either if it is com or net, you tell the regex engine to have a match. So coming here, gr character class A, E and y. So this regex with a character class is match these two, grey and gray. With alternation, what you can do, create a group 1, 2 and A and pipe and E. Now this regex is telling the regex engine that either pick A or E after gr followed by y and give it select it as a match. So for single character the behavior is similar, but the real power of alternation lies in words or complex regular expressions, where instead of single character we can have groups or multiple regular expressions. Now if you want to match regex.com as well as regex.net, what you do, regex / little period and form a group and create alternation com or net. So it will match both of these websites or both of these strings, of course. You can use as many options in alternation as you would wish for. For example, there is another site regex.org. What you can do is use pipe symbol and org. So again it is a match. You can add another pipe info, and here the website is regex.info. Of course, now this will be a little bit difficult if we use character classes, etc., and the code will be complex. Now here it is very simple. Now let's suppose you want to match hardworking man and hardworking lady in your test string. Hardworking is common, hardworking, and then you make a character class, not character class, sorry, alternation, and you write man, pipe, and lady, and here now with alternation, hardworking space a group man or lady, match anyone, and here it is matching man and hardworking lady. So this is alternation. Now let's suppose you want to match these files with these sort of file names and with txt, xlsx, docx, pptx, and extension. What you can do is first create a boundary, word file is common, then \w and star 0 or more, then a literal dot. So up to here is clear. \b is word boundary, file is common in these names, then anything after that, \w star, that means 0 or more, either file or files or file 1 2 3 or files 1 2 3 etc., and then a literal dot. After that, these are the extensions. So use alternation here, txt or xlsx or docx or pptx or okay, done. And now we close this parenthesis, and here you can see all the file names with extensions have matched here, and of course ending it with a boundary. And here is our complete regex for matching this sort of file names. So this is alternation and its use. Thank you. Hello, in this lecture you are going to learn about nested alternation. Nested alternation or nesting in alternation means an alternation within an alternation. Now first see simple alternation, Toyota or Honda. So this regex will select either Toyota or Honda, one word out of these two, and it is very simple. Of course, here is an example of simple alternation, Toyota or Honda within parenthesis. Now this regex is going to match Toyota, and after that it comes out of this group, and of course it will match one out of these two options, either Toyota or Honda. So it has matched Toyota first, and after that it will not bother to search for Honda, and it will come out of this group and move on to the next token. So this is simple alternation. Select or match anyone out of these two. A nested alternation can be this pink box. These two pink boxes are the two, these options, Toyota, Honda, Toyota or Honda, and these two options, this is the starting brace parenthesis, and this is the closing parenthesis. So these are the two options, and this is OR. So this is normal alternation. Within these two, now with Toyota, another alternation is created, and for this to a pair of parentheses, and within parentheses the options are 1000 cc or 660 cc. This is another alternation. And with Honda there is another alternation, 1300 cc or 2000 cc. Now the regex engine is going to pick either Toyota or Honda first, and out of Toyota it will either match 1000 cc or 660 cc, or if it matches Honda it will match 1300 cc or 2000 cc. So within alternation, more alternation. This is nested alternation. Now you can see there are four options: Toyota 660 cc, Toyota 1000 cc, Honda 1300 cc, Honda 2000 cc. Out of these four possible options, the regex is going to match or select only one option, because alternation is to match one option out of several options. First it will search for Toyota, and it finds here, it will search for 1000 cc. No, it will search for, it will move on to second option, 660 cc. It is a match, so Toyota 660 cc is a match, and it will move out of this group and move on to next token, regex token here. Now here I have changed the test string and writing Honda 2000 cc first, then Honda 1300 cc, then Ferrari, Toyota 660 and Toyota 1000 cc. Now the regex engine first will go for Toyota option, and it will not find here, so instead of going into 1000 or 660 it will go directly into Honda option. Okay, Honda, and then it will go for 1300 cc, not there. Okay, 2000 cc, and it finds a match, Honda 2000 cc. So as soon as the regex engine finds a match, it will move out of this group. What more you can do is add another option, alternation, Ferrari, and make it optional. Now total there are 1, 2 and 3 options, and the last option is optional. So this is all about nesting in alternation. Thank you. Hello. In this lecture you are going to learn about non-capturing groups. As we have already discussed that when we write element within parentheses, then a group is created. Full match is group 0, and then Regex engine starts naming the group from left to right as 1, 2, 3. So first I write here I like Toyota and Honda. So this is a full match, and I like Toyota and Honda is group 0. Now I put parentheses around Toyota, and this will be group number 1, and Honda, and this will be group number 2. So this is group 1 and this is group 2, and the whole regex is group 0. After that we can refer group by its number. Toyota is group 1 and \1, it will refer to Toyota. So you can see here this is a complete match. I like Toyota and Honda and \1 group number 1. So we don't have to write Toyota again, we have written the group number, and this is a complete match. So in case if I write group number 2, the match is Honda, because this is group 1 and this is group 2, and group 2 means \2 means group 2, and that means it will match I like Toyota and Honda. What if you don't want to capture any group? Like let's suppose Toyota, and we use question mark and colon. Now question mark and colon creates a non-capturing group. What is the meaning of this? This means that this whole match is group 0. Now earlier Toyota was group 1, but now it has become non-capturing group, and Honda is group 1 and there is no group 2, so it is giving a pattern error. So if we delete this one, the pattern error is removed. And now if I write here \1, and it is matching not Toyota this time, earlier it was matching Toyota, now this is matching Honda. Why? Because this is no group and this is group number 1. This group is actually non-capturing group and this is capturing group, and it has been assigned the position 1 or the number 1. So that's why I like Toyota and Honda and number 1, and number 1 is Honda, and it is matching here. If I remove this one from here, now again it is matching Toyota. Why? Because removal of question mark and colon makes this group 1 and this is group 2. And if I put question mark and colon here, then this is group 1 and this is match, and without that this is the match. So this is how you can make a group non-capturing. Thank you. Hello, in this lecture you are going to learn about assertions. You will use assertion when you want to match an element, which could be a word, a character or a group, if a certain word or element comes after it or before it. Now you can see here bill paid, bill not paid, bill paid, bill paid, bill not paid. You want to match bill only and only if paid comes after bill, but you want to match bill not paid. I repeat it again, you want to match bill only if it is followed by paid or paid comes after bill. When you look for a certain presence of a certain word after the element you want to match, this is called look ahead assertion. That means you are looking ahead your element you want to match. Similarly, in this example, this is free course, free, paid course. You want to match course only and only if free comes before course, and you want to match course. I repeat it again, you want to match course if the word free comes before course. This is called look behind assertion. As the name shows, you are looking behind a certain word. Now look ahead assertion and look behind assertion. Both are of two types, positive and negative. We are going to discuss these in the next lectures. Both of these, look ahead and look behind, are collectively called as look around. Look around actually matches characters or element, but then gives up the match, returning only the result, and that is yes or no, match or no match. That is why they are called assertions. They don't use the characters in the string, but only tell us whether there is a match possible or a match is not possible. Look around allows you to create regular expressions that are complex to create without them, if not impossible. So this is introduction about assertions. Thank you. Hello, in this lecture you are going to learn about positive look ahead assertion. Look ahead means you look the word after the element you want to match. When you want to match a word, a character or group, if a certain word or element comes after it, then this is called positive look ahead assertion. For example, if you want to match the word bill, if it is followed by paid, if paid word comes after bill, then only in that case you want to match bill. All other cases you don't want to match. The syntax of a positive look ahead is, first you write the element to match, like bill here, then parenthesis, within parenthesis question mark and equal to, this is for positive look ahead, question mark and equal to, this is for positive look ahead, and then the element which you want to be after that bill or after that element to match. Similarly, in second example, the currencies are here 100 United States dollar, 250 Japanese yen, and some other currencies, and you want to match the 3-digit number only and only if it is followed by USD. Number space and comes after that USD. So you want to match in that case only. Let's suppose you want to go for US dollars, and then later you would like to add them or do any operation. For this we will need positive look ahead. And how we are going to do that? \d plus, that means numbers. Could be better if we use braces and 3, because we know these are 3-digit numbers. So \d plus, and then parenthesis, question mark equal to, this is for positive look ahead, question mark and equal to, \s is for space, this space, and USD. This is what we want to have after this number. If this condition is satisfied, this regex will match these 3 digits only. Now let's see in our working environment. So here we want to match bill only if it is followed by paid word. So we start on writing the regex here, bill. Okay, it is matching all bills. Then after bill we create question mark and is equal to for positive look ahead, and then \s is space and paid and close that parenthesis. Now bill we want to match within this group, question mark and equal to, this is for positive look ahead, and \s is for the space, and paid is the word which we want to have after the bill. So it is matching only bill when it is followed by paid, bill followed by paid, bill after it paid, bill after it paid is written, and it is not matching bill not paid and bill not paid. Similarly, in this example you want to match this 3-digit number only and only if after this number comes capital USD. Otherwise you don't want to have a match. So \d 3, as we know there are 3 digits in our number, and then start on the parenthesis, within parenthesis question mark is equal to positive look ahead, then there is a space \s and USD, and close this parenthesis. Now you can see it is matching 3-digit number only and only if the number is followed by USD, or USD comes after this number, so it is matching only these numbers. It is not matching USD, of course. So this is positive look ahead. Thank you. Hello, in this lecture you are going to learn about negative look ahead. When you want to match an element, if a certain word does not come after it, then you use negative look ahead. The syntax is element to match, parenthesis, question mark and exclamatory mark, that means not, and then the element that should be there, or that should not be there, of course, in this case. Now here in this example, let's suppose you want to match bill if it is not followed by paid. Now this time you want to match bill if it is not followed by paid, otherwise match everything else, but not bill followed by paid or paid comes after this bill. The syntax will be bill, parenthesis, question mark and exclamatory mark, not a negative look ahead, backslash s is for this space and paid is the word paid. So this regex tell the regex engine match bill if anything is after it but paid. So let's first check this example. So here we want to match bill if it is not followed by paid or paid does not come after it. So the syntax is question mark and exclamatory mark, that is negative look ahead, backslash space is there and paid, and it closes. So you can see all the instances of bill are matched which are not followed by paid here. So simple. Now in this second example, you want to match these 3-digit numbers if the numbers are not followed by USD. Like you don't want United States currency and all the other currencies are acceptable. So you are going to leave US dollars and select or match all the other currencies. For this, the regex will be this one. Here backslash d and quantifier is 3, so 3-digit number, question mark and not, that means negative look ahead, backslash s is for space and capital USD, United States dollars USD. This regex is telling the regex engine match all 3-digit numbers that are not followed by USD, match all 3-digit numbers which don't have USD in capital after them. Looking it in regex engine, so you can see here backslash d, any number, 3 is quantifier, 3-digit number, parenthesis, question mark, exclamatory mark, negative look ahead, backslash s is for space of course and USD, the word which should not come after number, otherwise any word can come after number. So you can see the match here, it has left USD and it has matched Japanese yen and Italian lira, etc., all the other numbers. So this is negative look ahead. So these are very simple regular expressions. You can experiment with, like use alternation here, like you don't want to match USD and JPY, Japanese yen and US dollar, otherwise you want to match any other currency. So here the structure will be backslash d, quantifier 3, any 3-digit number, parenthesis, question mark, exclamatory mark, negative look ahead, that means this should not come, backslash s is for space and here alternation, if it is JPY or USD don't match, otherwise match. Looking at regex engine, okay, first we write backslash d and quantify 3 and then start our look ahead and question mark, exclamatory mark, negative look ahead, and after this negative look ahead there is a space and after space we use alternation, and we use JPY pipe USD. Close this alternation, close this one, the negative look ahead, and you can see here the result. It has left USD as well as JPY, and it has matched all the other currencies. So you can use alternation and all the other structures you have studied with look aheads. Thank you. Hello. In this lecture, you are going to learn about positive look behind assertion. When you want to match an element, if a certain word or element comes before it. So let's suppose you want to match course if it is preceded by free. So only in that case you want to match course, otherwise you don't want to match. So paid course should, in this case, course should not be a match. So their course should be a match if free comes before course. Simple. Now the syntax is question mark less than equal to. That is syntax of positive look behind. Now the regex for this is course which you want to match. Within this group, question mark less than equal to is for positive look behind. Free is the word which you want to have before course. Free should precede before course. Backslash s, of course this is a space here. Okay, you want to match all the instances of course which have free before them. So first we write course, and it is matching all the courses here, all the course word here. Now question mark less than equal to positive look behind, then the word free backslash s. So you can see only those course are a match which have free before them. This is positive look behind. So positive look behind when you want to match an element if a certain word comes before it. So the person is looking for free courses, of course. The second case here, second example. So there is social worker, hard worker, lazy, poor, intelligent worker. You want to match the word worker if it is preceded by social, and you want to have a match of worker if and if only social comes before worker and no other word. So here these are the social, hard, lazy, poor, intelligent worker, and this is the regex worker, and before worker a group, question mark and less than equal to, this is for positive look behind, and social we want to have before worker, and backslash s is for the space, of course, and only that worker is a match which has social before it. So if I write another social worker here, social worker, now this is again a match. No other worker should be a match. My worker, no match. So this is positive look behind assertion. Thank you. Hello. In this lecture you are going to learn about negative look behind assertion. When you want to match an element, if a certain word or element does not come before it, then you use negative look behind assertion, and the syntax is question mark less than exclamatory mark. Now here is the test string: C book, C++ book, Java book, Python book, Ruby book, and chemistry book. You want to match book if chemistry does not come before book. So you don't want to match book in case chemistry precedes book. Otherwise all other matches are allowed. So the syntax will be question mark less than exclamatory mark, which means negative look behind assertion. And chemistry, you don't want the word chemistry before book, backslash s is for space, and book which you want to match. So simply you don't want a certain word or an element before your match. Now here you are going to match book. Okay, you want to match book, but before that we write question mark less than and not equal to chemistry backslash s. So it is leaving chemistry a book, and it is leaving the word book in case chemistry is before book. Otherwise it is matching all other book word cases. So this is negative look behind assertion. One important point to note is look around is atomic. Now what does this mean? It means that as soon as the look around condition is satisfied, the regex engine forgets about everything inside the look around. It will not backtrack inside the look around to try different permutations. It simply comes out of that group. Hello and welcome to Dates in Regular Expression. In this lecture, you are going to learn how to write regex for dates. Now here you can see dates written in different formats, or with forward slash and with hyphen. So these are a few dates I have written here, and First, to write a regular expression for any data, first we have to analyze the data. Now in these examples and in the next lectures, you have to learn the technique, how to divide and conquer, how to see the pattern in data and write corresponding regular expression for that. That is very much necessary about planning after watching and analyzing your data. So first we analyze our data and we see this is here all of these dates have a number, then a separator / or hyphen, then again a number, then again a separator / hyphen, and then again a 4-digit number. So better to separate them. Okay, here we can see a little bit more. Okay, now so this is our data analysis for writing regular expression, because all the dates have something or many things in common, and of course there are subtle differences also. So we have to analyze our data. Actually, I have divided these dates into a list of column. This is first column, this is second, this is third, fourth, and fifth. Now if we write regex for each column and then combine them, then it will be regex for dates, of course. Now here if you look at this column contains numbers 1 digit or 2 digit. 1 digit number, 2 digit, 2, 1, 1, 2, 1, 2 digit number. So this column contains numbers either 1 digit or 2 digit number. For that we can write the notation \d. With it we can use a quantifier, minimum 1 and maximum 2. Well, just like that. This is \d for digits or number, and maximum 1 and minimum 1 and maximum 2. So we are using quantifier with that. Now here in this column there are / and hyphen. So we can use a character class of / and hyphen, and our regex engine is going to pick anyone out of these two or out of that character class. So this is the character class, and this is hyphen, and this is / and to escape this / we will use a / to escape this special character of this / This / will make this / a literal character. Again, number, single or 2 digits, so the same pattern here, \d, minimum 1 and maximum 2. And for this / and hyphen, again similar case, using a character class for hyphen and /. Now for this, all are numbers and with 4 digits in each number, so 1, 2, 3, 4, uniform. So \d or fixed length quantifier 4, so \d 4. Now combining all these, this is our regex for dates, a complete regular expression for matching dates of these format. So we have combined all these into one regular expression. So this is how you can analyze the data. Then after analysis, you can break them into separate sections or classes or column, and write regex for each column, and then combine them to form the complete regex. Very simple, isn't it? Now looking here, these are the dates I'm working here in Regex engine, and to start with \d, quantifier is 1 to 2, minimum and maximum. After this we ought to have a character class hyphen / character class close. That means first is digits, minimum 1, maximum 2, then either pick a hyphen or a /. Then again a number d, and this number is of minimum 1 and maximum 2. Then again a character class hyphen / and in the end \d, fixed length 4 digit number. And you can see here all the dates have matched. Now you may use word boundaries here, \b and \b for a complete match. So this is how you can write regex for dates. I hope you have learned how to write regex for complex data. Thank you. Hello. In this lecture you are going to learn how to write regular expression for zip or postal code. Zip codes are a system of postal codes that help the mail to travel efficiently and quickly. Now there are quite a few types of zip or postal codes. We are going to discuss some of them, of course. The simplest postal code is a fixed digit number, like a 5-digit number 75468, and we have to write a regex for that. Now if it is a fixed digit number, let's say there are 5 digits, so the simplest regex for this will be \d, and quantifier is 5, so it will capture all 5-digit numbers. Let's see here in regex engine. Here in example there are two 5-digit number, and these two are extra numbers to see if every number is not matching. \d and quantifier is 5, and that's it. It is matching these two, full match, and to avoid matching this one you can place a word boundary so that it matches these. Okay, now this is still matching here. Instead of word boundary, place caret at the start and $sign at the end, and to anchor it, and here select the multi-line mode so that it searches for each line. So now you can see with caret and $sign anchoring these, now only 5-digit number or postal codes or zip codes are matched, and these two, or if something less than 1 2 3 4 or 1 2 3 4 5 6, there are no other matches. If I convert it to 5, this is a match. If I add a number, no match. These two are full match here. Now the second type of postal code is a fixed digit number hyphen and then again a fixed digit number. Like in United States of America, the postal codes are like 5 digits hyphen and then 4 digits, and most of the people only use these first 5 digits, and they don't know about this one. However, the full postal code is like this one, 5 digits hyphen and then 4 digits, and the regex for this will be \d quantifier 5 for these 5, then hyphen, then \d. There should be braces here, like here there should be braces before 4 and after 4, and now this will be the regex. Now we will look it in our regex engine and we will use braces for 4 also. Now here if we see 5 digits hyphen 4 digits, 5 digits hyphen and 4 digits, so here adding a hyphen \d fixed 4 digits, and these two are match. So 5 digits are hyphen and 4 digits. So this is how to match postal code with hyphen. Now let's suppose if you want to match this and this, either if postal code is written 5 digits or 5 digits hyphen 4 digits, you want to match both these. How to do? Very simple. Make this part optional. How do we make optional? By putting parentheses and using a question mark after the parenthesis, this group. So hyphen \d with quantifier 4 and after parenthesis a question mark makes this whole group optional. So now this is matching fixed 5-digit postal code or 5-digit hyphen 4-digit postal code. Now we see a postal code series with complex format. This is mainly used in United Kingdom. Now if you look at these codes, they seem to be somewhat complex, and this regex also seems to be somewhat difficult, but actually it is not. Now let's divide and rule, or divide and conquer. So these are the formats, and they have one space between them, so we separate them by this space. Now these are the postal codes. This is one space. Of course this is not a tab, this is one space, but I have separated the first part and the second part of these codes. Let's do the simplest part first, or the second part. So all of these postal codes second half is same, that is 9AA. Here 9 stands for any digit, not only 9. This A stands for capital from A to Z, any alphabet. This A also stands for any alphabet from A to Z, uppercase. So 9AA, 9 means any digit, so \D for first A, and that is character class from A to Z, uppercase, and quantifier 2, just like this. So this is the regular expression for this second half of all these postal codes. \D for number, A to Z, these alphabets, uppercase, and quantifier is 2, means A to Z 2 times. So simple up to here. If we look at the first half of all these postal codes, one thing is common, that all of them start with alphabet, though in some cases there are 2 alphabets, and in some cases there is only one alphabet, 2A, A, 2A, and 2 times A. So this means a character class A to Z, uppercase, minimum 1 time and maximum 2 time. Simple. Just like this, a character class A to Z, minimum 1 time, in some cases 1A, and maximum 2. Add maximum 2 alphabets before this number. After 1 or 2 alphabets there is a number, 2A9, 1A9, 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 2A9, 2A9. In some cases there is one number, 999. In some cases there are 2 numbers, 9999. That simply means a digit, minimum 1, maximum 2. So \D, minimum 1 and maximum 2. So these digits are covered. In some cases there is space after digit, but in some cases after digit there is A. That means another character class, but this time only once. In some cases there is no A after digit, in some cases there is alphabet A after number, so we make it optional. Very simple. So that's it. It is simple if we divide it, if we analyze it, and if we write if we see trends or patterns and we write accordingly. So this is whole okay, let's say this is space, so we use \S. If we combine these two, it forms the complete regex, which is the same as we see here. Of course, / is at the beginning and at end, and for anchoring, place caret at start and $sign at the end. So now this regex seems very simple. Of course, we have analyzed the data and we have constructed a regex according to the data pattern. Now here our string starts with alphabets, uppercase of course, and minimum 1 and maximum 2. After that we have a number, and this number minimum 1 time, maximum 2 time. After this number, optional A to Z, A to Z 1 character, and question mark makes it optional. Backslash S space backslash D 1 number, and after this backslash A to Z, and the quantifier is 2 because it is repeated 2 times. So you can see here all codes, now all postal codes of this nature a complete match. You can anchor it by placing caret and $sign. I don't put extra sign so that the code doesn't look that much complex and you can comprehend it easily. So this is all about postal code. Thank you. Hello. In this lecture, you are going to learn about how to write regex for IP addresses. IP addresses are usually in the form of, are always in the form of x dot x dot x dot x, where x could be any number from 0 to 255, and x can be like 0, 0, 0, 3 zeros, or 001 or 011 or 099, etc. Hypothetical IP could be like 0.0.0.0, or at maximum it could be like 255.255.255.255, or any number like 9.7.8.122, because x is from 0 to 255. Now you would say, let's write \d because these are numbers. But \d here will not work, as \d is a digit from 0 to 9, and we have some constraints. This number cannot be more than 2. This cannot be, these two positions cannot be more than 5. Similarly, we cannot write character classes like a character class of 0 to 5, because sometimes we have to write numbers like 0 or 000 or 001. So both these solutions won't work. Hence, we need to think a solution for this. Now, if you look at the pattern, it is x dot x dot x dot x. Now, there are two things. First one is dot. Now, you can write this dot with \, period, of course. One thing is left, and that is x. If you manage to write a regex for x, that is from 0 to 255, surely you will solve this problem. You will write the regex for IP address. So we have to look for x, writing a regex for 0 to 255, 0, 00, 000, 001, 011, 099, etc. And after writing regex for x, we can simply repeat it 3 more times. Total it will be 4 times, of course, and that will be it. Now x could be from 0 to 255. We are going to break down this range into 3 parts. The first part is from 250 to 255. 25 is common here. Second part is from 200 to 249, and the first part is from 0 to 199. Then of course we could have 3 times 0, 2 times 01, 010, 099. But the main thing is division of, or breaking down of 0 to 255 into 3 parts. First one is 250 to 255. Now here in regex engine I have written these some odd numbers, some numbers which are not in range, and numbers from 0 to, starting from 0 up to like here 255, and few numbers after that to check either it is matching numbers greater than 255 or not. So this is the first breakdown from 250 to 255. What we are going to do is write regular expression for this part, for this part, for this part, and then combining them with alternation. So here from 250 to 255, 25 is common, and character class should be 0 to 5. 25 is common, and character class is from 0 to 5, and a full match here 250 to 255. Very simple. For this section, this is full match, 25 common, character class from 0 to 5, and we write here solution for this part 25 and from 0 to 5. Similarly, if you want to write a regex which could match any number starting from 200 up to 249, now in all these numbers 2 is common, 2 is here, and after that the second place at minimum could be 0, and at maximum it could be 5. So 0 to it could be 4, of course, not 5, this is 4. So from 0 to 4 this place, and next one minimum 0 and maximum 9. So next character class is from 0 to 9. Now this regex is going to match any number from 200 to 249. Let's see here. So this is where the range starts, from 200. Now 2 is common. The first range is from 0 to 4, and second range is from 0 to 9, of course. And this regular expression is going to match nothing less than 200. You can see complete match, and nothing more than 249. So that means this is first part, this is second part, and now one part left, and we will do the problem. We will solve the problem. Now here the number is from 0 to 199, and we are going to match these numbers, any number from 0 to 199, and also these sort of numbers. So first we are looking to 0 to 199. We have to keep in mind that this number can be a 3-digit number. So we are going to write 3 character classes for this number, and the first character class, because number is from 0 to 199, so first character class can hold only 0 or 1. So the range will be 0 or 1 or 0 1. The second place at minimum could be 0 and maximum 9. Similarly, the third place, minimum 0 and maximum 9. So this character class, so these are the 3 character classes. First one from 0 to 1, here number could be minimum 0, maximum 1. Here it could be minimum 0, maximum 9, minimum 0, maximum 9. From 0, 0, 0 to 199, because it is 0 to 199. And we have made this class and this class optional. Let's suppose in case of if there is only 0, so this and this is optional, and only one character class with 0 or any number from 0 to 9 is going to work for this, for numbers from 0 to 9. And this also covers for this 0, 0, 0, because this is optional, but if there is a 0, it will match. 0 to 9, 0 will match. 0 to 9 optional will match. So this is going to match 0, and this is also going to match 3 times 0 or 3 times 1, etc. Now combining these 3 ranges, these 3 breakdown ranges, yes, here they are, and we will simply not join them, because a number could be either in this range, or in this range. So this is either this, or this. So this is simply a case of alternation. You can see here, this is the alternation, pipes and parentheses at start and end, and now this will work for x. So here x is equal to this. This code is going to get any number from 0 to 255 and the numbers of type 0, 0, 0, 0, 0, 1, etc. So this is x. We are going to write it in our regex engine. So simply copying this and pasting in regex engine here. Okay, this is first range. Optional means either the number could be from 250 to 255, or the number could be from 200 to 249, or the number could be from 0 to 199. After writing this, if I don't make this one and this one optional, what is going to happen? These 3 character classes will match 3-digit number only. You can see, okay, it has start matching from here 255 and decreasing up to, yes, 100. So only 3 digits number. So if I make this optional, and if I make this one also optional, now you can see it has matched all the other numbers from 0, 1, and it has also matched 0, 0, 0, 0, 0, 1. So this regex is matching x, where x is any number from 0 to 255 and also some special number like 0, 0, 0. And the regex we have just written in regex engine is this one, but the structure is x dot x. For writing dot, backslash dot to escape this meta character. Again, this is x, just simply copying this one because x dot x dot x. Backslash dot, another x with backslash period. So this is the last x, and after this there is of course no dot. X dot x dot x dot x. So x dot x dot x dot x. This is a complete regex. Now let's see matching it with some practical IP ranges. Now writing the whole regex here, it is matching all possible combination and not matching the IP addresses which are incorrect, like 256 or 755, but it is matching 4 zeros or 2554 times with dots of course, and this address, and it has also formed groups. These groups are formed so they can be further analyzed and studied. You can make these groups non-capturing by simply writing question mark and colon before each group. So this is how you can create regular expression for IP addresses. Thank you.